Okay, the last class we have introduced the basic work leisure choice model, and we have seen the budget constraint, preference, and the optimization, right? So this is just like a standard utility maximization with two goods, right? So we have a budget line, we have an indifference curve, and when they meet, when they touch each other, that is the optimal point, which is P, okay? And at this point, what we know is the tangency condition is satisfied. So basically what it means is the slope of the indifference curve and the slope of the budget line should be equal. So MRS, slope of indifference curve, MRS or MUL over MUC should be equal to the slope, which is W, okay, the wage rate. So this is for the interior solution, meaning that the individual chooses some consumption and some leisure, okay, not extreme, okay, so combination of the two. We will see the corner solution shortly, but first, okay, the normal situation is the when the tangency condition is satisfied, okay, then we have an interior solution. Okay, if we know the tangency condition, then using that we can actually solve some of the questions, some of the problems with mathematical formulation of utility function and the budget constraint. Okay? Let me give you a very simple example like here. So utility function, let's say, is given by this 0.7 times log C plus 0.3 times log L. Okay? And from here, later what we need is this, right? So what we need is obviously the marginal utility of leisure and marginal utility of consumption function. Okay? So what is the marginal utility of leisure function? Marginal utility of leisure function mathematically, how do we do that? Differentiate the utility function with respect to what? MUL, differentiation of U with respect to what? L, okay? So we just differentiate it. And you see the same way, differentiate U with respect to C. Then if you know a little bit of calculus, it's easy to see that this is the MUL and MUC functions, okay, the respectively. Okay. Then what we need is the information for the budget constraint. Let's say the wage rate per hour is $9, and the total hours are given by, let's say, 24. And non-labor income, let's say this person has $204. Okay? So we write down the budget constraint for this person. The budget constraint should be C equals W and what? T minus L plus B. Okay? So what we have is C is just the C, and W is 9. Okay? T is 24. V is 204. Okay? So that's the budget constraint. And to find the optimum, we have to remind ourselves of the tangency condition, MUL over MUC equals W. So here we have already MUL and MUC and W here, so we just do that. That should be 3C divided by 7L equals 9. Okay? And this one gives a condition that, that the optimal solution should satisfy, which is C equals 21 times L. Okay? So this is a one condition that the optimal solution should satisfy. C equals 21 times L. There is actually a second condition, which is, what is the second condition the person should satisfy? Must be what? should be the budget constraint. Why? No, look at the optimum. When you look at the optimum, this optimum should be on the budget line, okay? Which means any optimum should satisfy this budget line condition, budget line. And obviously the slope of the indifference curve should be equal to the budget line. That is the C equals 21 times L. But as you can see, that slope, the same thing can happen here, right? So you can have the slope like a budget line, but it's not the optimum. You can have a slope like a budget line here, but it's not the optimum. The optimum should be on this, okay? So actually there are two conditions, okay? So implicitly, it should satisfy the condition for the budget line and the tangency condition, okay? The budget line is it's an implicit condition. So what we have, and you just put this into the budget constraint, and then you can easily solve it. It's just the two equations, right? Two equations and two unknowns. So it should give us, okay, the unique solution, which is L equals 14. So L equals 14, that means H working hour should be 10. Okay, it's simply 24 minus 14, so H is 10. And then if you put H 10 or L 14 into here, then you can see the consumption should be $294. Okay, get it? Okay, questions? Okay, you should be able to do this type of simple mathematical calculation. Okay, once you understand the condition for the interior solution. Okay, that is a textbook exercise, so we can try it later, the exercise. Okay, now let's move on to the next one. Okay, here what we are interested in is what happens if non-labor income changes? What happens if the non-labor income changes to the labor supply behavior? Okay, so non-labor income may increase or decrease, right? Non-labor income is such as like the dividends, right, or rent or anything that you get, the individual gets without any work. Okay, so for example, in this case, let's say this person had V0 initially, and this individual's optimal choice is point D. Okay, now let's assume that this individual now has higher non-labor income. Okay, let's say the rent went up. This person has a property, and let's say this person now gets higher rent. Okay, because of, let's say, the property market condition. So V0 goes up to V1. Okay, now graphically, how do you show it? Just that this point will go up by this amount, okay, and then the budget line itself now should start at here, okay, not here, okay, but with the same slope. So it's gonna look like this. Okay, it's just parallelly, you just shifts up the budget line, okay, by the amount of the increase in the non-labor income. Then what would happen to individuals, let's say, leisure choice? More leisure or less leisure? More or less? It should be more leisure. Why? Why? Because theoretically, we assumed what? Leisure is a normal good, right? So by the definition of normal good, higher income should make this person to choose more leisure. Okay, that's why we define leisure is a normal good. That's why we assume leisure is a normal good. Okay, so which means basically that if we draw graphically, we just move the indifference curve shifts upward, okay? Upward and outward, actually. So then, gonna move something like this, and then we reach the point like E, okay? So this at this point, leisure increase, so which means what? Labor supply increase or decrease? Decreased, okay? If we assume that leisure is an inferior good, then what should happen? If leisure is an inferior good, then the opposite will happen, right? Leisure consumption will decrease. So leisure will be less leisure will be chosen, and which means more labor supply. Okay. So depending on what we assume, actually we can have two cases. But here we choose to assume that leisure is a normal good. Is this a good assumption? Does it make sense? You have non-labor income, then you want to work less. Let's say you have higher non-labor income, you want to work less. Is this more reasonable, or you have higher income, so you want to work more? The former or the latter? Which one is more reasonable? Former seems to be more intuitive way of thinking, right? I have more money in my pocket, so I want to have more time off, right? Probably that's what happens to most people. Okay, it is unlikely that I have higher income, higher non-labor income, so I want to work more. You know, that gives me more desire to work. Probably not likely to most cases, right? And if we actually look at some empirical evidence, then it seems like that's the way it actually works. Yeah, you know, if you look at the textbook, page 43, you have textbook? Nobody has it? If you look at, this is a great textbook, as I told you. If you look at the textbook 43, it talks about what happens to individuals' life when they won the lottery. Okay, that is very interesting discussion. Okay, if you have a translated textbook, it also has the same section about the lottery. Okay, so what do you think gonna happen if you won the lottery? Will you work more or less? Work less or more? Probably work less, I guess. So there are interesting episodes about those. Okay, here. So so it says like this, like they studied 1,000 lottery winners, and then the person who won more than $50,000, okay, and 1/4 of those people who won more than $50,000 left the labor force within a year. So they quit their job, okay, if they won the $50,000. If they won the $1 million, 40% left the labor force. Okay? And if they won a small lottery, okay, then it's less. Okay, so that's the thing. Okay, now we talked about what happens if non-labor income changes. Then let's see what happens if the wage rate changes. Okay, so wage rate may go up or may go down. Okay, if it goes up, then what happens? Okay, that's the thing. One thing that happens is that wage rate goes up, that means in one side, higher income. Okay? Because for example, let's say your wage rate goes up from, let's say, $10 to $12. You worked for 10 hours a day, let's say, to make calculation easy. So then you won every day, you earned $100. Now it's 12, so you earn now $120. So you don't do anything, your just income goes up, right? So that is what? You have a higher income, so since leisure is a normal good, then what happens to labor supply? Labor supply should increase or decrease? Increase or decrease. If you're higher income, so labor supply should. There are only two answers. It's either up or down. Increase or decrease. Increase or decrease? Should decrease, right? Leisure is a normal good. So that's what it says. Higher income for given work hours, consume more goods, and enjoy more leisure. Which means less work, okay, or lower labor supply, or higher demand for leisure, the same thing. Higher demand for leisure, lower labor supply, same thing. Okay, now that's one thing that happens, but there is another possibility. What's the other possibility? The other possibility is that wage rate is not only the source of income, but also it's a price of leisure, which tells you how much you lose when you skip work. Okay? So that means what? Wage rate goes up. So price of leisure goes up. So you demand more leisure or less leisure? Less leisure because it's more expensive. So what happens here is that we just basically decompose the effects of wage rate change into two things. One is the change in income. The other is the change in the price of leisure. We basically artificially decompose this effect into two. Obviously, in the real world, this effect that happens at the same time as just one, okay, as just one entity. But we just divide them into two things theoretically. One is this, and the other one is leisure becomes more expensive relative to goods, so substitutes goods for leisure. Okay, so relatively now the leisure is more expensive. Relatively goods are less expensive or cheaper. So you consume more goods and consume less leisure. Substitute goods for leisure. So then, more work or less work? More work. Okay. So that's the more work. So we have names. The first one we call it the income effect. Second one we call it the substitution effect. Okay. Income and substitution effect obviously are the normal names for this type of analysis, right? If you do microeconomics, you already heard these two terms, income and substitution effect. Okay. Normally, if you have two goods, actually income and substitution effect goes to the same direction, right? And the price of a good increases, for example. Then income and substitution effect both decrease the demand for the goods. Okay? You know what I mean? Okay? But in this case, the effects, okay, are to the opposite directions. Okay? So income effect, when wage goes up, income effect makes this individual to work less. And substitution effect makes this individual to work more. Okay? So there are two opposing effects in this. So at the end, work more or less? At the end, more or less? Theoretically, more? Less? It depends on, obviously, which effect is bigger. Okay? We can have two cases. Okay? So work more or less, or they cancel out each other, maybe. No change. Okay? It is important to understand these two effects are behind income and substitution effect. Okay? So then we can understand better that how the wage rate affects the labor supply behavior, and later we will see the other things that related to wage rate. Okay. So when the wage falls, now let's try. Wage rate falls, then what happens to income? Income effect part. So income effect part, let's think of wage rate falls. Then income is like lower, right? So labor supply will increase because they demand less leisure. So that's the income effect part. So by income effect, work more, labor supply increases. By sufficient effect part, price of leisure is lower, so they demand more leisure, so labor supply will decrease or increase? Will decrease. Okay? So by income effect, labor supply will increase. By sufficient effect, labor supply will decrease. So that's the thing. So obviously here we obviously don't know which effect dominates. Since we don't know which effect dominates, so theoretically, anything can happen. Okay, labor supply may increase, may decrease, or they cancel out each other. Okay, if you are interested in mathematical treatment of this, then obviously this one goes to closely related with which equation. In microeconomics, you heard this term, right? Slutsky equation. Okay. So if you know the Slutsky equation, okay, then income and effect and sufficient effect, it is shown in the Slutsky equation, and you can see what happens. In the textbook, go to the mathematical appendix, and section 2 that is the Slutsky equation. Okay. So if you are interested in those mathematical treatment, please look at the mathematical appendix of the textbook. Okay, anyway, so intuitively, okay, we can make an argument like this. Okay, so wage rate changes two things, right, at the same time. One part is income, the other part is the price of leisure. Okay. Well, there is one thing that worth mentioning. Let's think of an individual who's not working, let's say, who's not working at all. Okay, we will talk about it later, but let's do it in a little bit in advance. Say an individual who does not work at all, and this individual obviously can get the wage rate, right? So given the market wage rate, this person is not working. Well, let's say the wage rate this person can get goes up. What happens to this person's labor supply? Increase or decrease? Think of income and sufficient effect. What is the income effect for this person? What is the income effect? Wage rate goes up. Then what happens to this person's income? What happens? Okay, you look at this. Whether the income changes or not, we should look at what happens to this person's income if this person does not change anything. Okay, what happens to this person's income if the person does not change anything? This person was not earning any money because this person was not working. So that means there is no change in income. Okay, so for this person, there is no income effect. Okay, so price of leisure changes. Okay, but not the income part. So for that person, there is no income effect. So there is only one direction. So if the person is not working and the wage rate goes up, then this person is likely to increase labor supply. Okay, but we will talk about it later. Okay, more detail about that. Okay, so there's income and sufficient. It is important for you to understand what those two effects are and to apply, okay, these effects to the real situations. You get it? Questions? Income and sufficient effect? Yeah. So income effect, talked about it, and sufficient effect, we talked about it. Okay? So total effect depends on which effect dominates. Okay? If the income effect dominates the substitution effect, or substitution effect dominates the income effect. Let's see. First part, okay. Now we have seen the intuitive analysis. Now let's do a little bit of graphic analysis, okay, which is actually quite important to understand the other theories. Okay, let's see. Now let's see. Look at this case. Okay, this is the before any change happens. Okay. Now let's increase this person's wage rate. What happens here? What happens to this diagram? What changes? The slope of the budget line will change. Okay? So it will become like this. To make things easy, let's make W1 really high compared to W0. So it goes up like this. Okay? Then what is the optimal choice? Okay, to the optimal choice is simple. Optimal choice is just to move this indifference curve upward until it touches the new budget line. Okay? It's simple. So it's like E. Okay? So it changes from D to E. Which effect dominates? Substitution or income effect. Wage goes up. By income effect, this person should work less or more? Less. By substitution effect, work more or less? Work more. Okay? So for this person now, work less or more? At the end, work more. So which effect dominates? Substitution effect dominates the income effect. Okay? So once you see that, okay, the leisure decreased or work increased, okay, that means substitution effect dominates the income effect. Now how do you show using the graph? What you have to do is to graphically decompose the income and substitution effect. The way of doing it is to show the income effect. Let's assume, hypothetically, let's assume that there has been no change in income, no change in the wage rate, but changes only in the non-labor income. Okay, up to the point where this person can achieve the new utility level U1, which means we draw a hypothetical budget line that is parallel to the old one because we assumed no change in the wage rate. So that means the slope should be the same. But only the change in income, so height will be different. Height will be higher because it should touch the new indifference curve, new level of indifference curve. So if you draw that, then you can see that, okay, D to D prime. So if that happened, then the optimal choice would be D prime. So the movement from D to D prime is due to what effect? Should be the income effect. Okay, D to D prime. So this, look at this hypothetical budget line. This one is basically has no change in the wage rate, only in income. Okay, D to D prime. So that is how we show the income effect. Okay. Then now what we do is that we assume that there is a subtle definition of income. But anyway, let's assume that income is fixed, but only change in the price of leisure, wage rate. So that is D prime to E, which is what? What effect? Substitution effect. Okay. So as you can see that income effect increases leisure, substitution effect decreases leisure. Now the substitution effect is bigger than the income effect, so at the end, the labor supply will increase. Okay? Now you should have done this type of exercise before. Okay? If you study, you know, what is it? Microeconomics. Okay? There's this like some decomposition. What decomposition is it? Slutsky decomposition or Hicksian decomposition, whatever, right? I think that's the name. Okay? But anyway, what you do is when you try to show the income and substitution effect, this is what you do. We draw a hypothetical budget line that is parallel to the old one, but touches the new indifference curve, okay? And then we define the movement from the original point to this hypothetical point. We define it as the income effect. And the move on from this hypothetical point to the final point, we call it the substitution effect. Okay? So this is the very important diagram actually. Okay? You should try to do it yourself using your own hand. Okay? It may show up in the exam questions. Okay, now let's look at the incoming effect is bigger than the substitution effect. We can draw that same thing. Okay, here what we do is that this is from the textbook. There is a point that, let's say this individual was at point P and wage goes up from EF to EG, and then the final point is R. Okay? So P to R. So leisure increased. So which effect dominates? Which effect? Income effect dominates substitution effect. How do you show it? Okay, the same thing. We draw a hypothetical line, budget line, that is parallel to the old EF line. So DD has the same slope as EF, but this one has higher height. Okay, and it touches the new indifference curve. Okay, so P to Q is what effect? P to Q is the income effect. Then substitution effect is from what to what? Q to R is the substitution effect. So as you can see, the P to Q much bigger than Q to R. So income effect dominates the substitution effect. Okay? Questions? Okay. So this is a very important exercise to decompose income and substitution effect. Okay. So okay, so we have seen so far the interior solution. Okay, work. How many hours to work? Okay. Okay. So we have covered the interior solution, but now we have to cover the corner solution. Okay, corner solution. So there are two corner solutions possible, because there are two corners. One is here, the other one is here. Okay? So in this case, something like this. Okay? In this case, something like this. Okay? So obviously that. So if we have very flat indifference curve, okay, then we can have a solution like point D. Okay? So at point D, what happens? This person works all the time. No leisure time, okay? Only working. And if the indifference curve is quite steep, okay, then what happens here? This person, no work, okay? The consumption is only with the non-labor income. Okay? You know, last class we have talked about the slope of indifference curve, right? If the preference for leisure gets stronger, then slope of indifference curve gets steeper. Okay? So it's not coincidence that steeper indifference curve can lead to solution like this. Okay? No work. Okay? If it's flat, then relatively this person has lower value on leisure but higher value on consumption. So if it's flat, it's likely like this. Okay? So obviously everything else equal. Steeper indifference curve usually means lower labor supply. Flatter indifference curve usually means higher labor supply. So, you know, these two conditions, I mean, mathematically it is easy because at point D, wage rate is higher than MUL over MUC at any point. Okay? So look at MRS at any point. the MRS is lower than the wage rate. So this person ends up working all the time. And the other case is the wage rate is lower than the MRS at any point. So this person is end up working no hour. W is less than MRS. Okay. Which one is point D is common? Working all the time? Point E, is it common? Point E, is it common? Point D is rare, I guess. Point E. Common? Yeah, there are actually lots of people who don't work at all, right? We have seen the statistics. Labor force participation rate. Think about it. If you are not in the labor force, you are not only, okay, you are neither working nor looking for work, which means what? My optimal choice is just not finding work at all, okay? That means what? That means that person should be here, like this, okay? So, this is very common actually. Substantial percentage of people, working age people, are choosing point E, okay? Some probably not working because there is no job available, but lots of people actually choosing not to work because they do not want to work. Okay? So that situation we can show theoretically like this. Now let's think about that situation. What does it mean? Let's say you don't want to work at all. What does it mean? Does it mean that for any wage you don't want to work? Think about it. You know? You guys, how much can you earn if you work now for an hour? About minimum wage? Huh? Which is, in the US dollars, is probably about $5 an hour. Okay? Right? So would you work for $5 per hour? Raise your hand. I'm willing to work for $5 per hour. I'm giving up this study and I'm going out to work. $5 per hour. No one. What if it's 10? $10 per hour. Think about it seriously. If they give me $10 per hour, I'm willing to work. Raise your hands.
Depends on the job.
Think of a common job. Think of a job that, let's say, a job that, I don't know, work as a cashier in a convenience store. Okay? So it's honest money. So $5 per hour as a cashier, would you be willing to work? $10 per hour. No? $20 per hour. Now we have quite a few. A lot. $30. $40 per hour. Think about it. You just stand at cashier, you can get $40 per hour. What if they give you, let's say, $500 per hour? I'm not going to work for $500 per hour at cashier. Raise your hands. I'm not going to work. 500. Think about it. What does it mean? You are not working because the wage is too low. You know, if the store can offer you a higher wage, actually they can make you work, right? If they give you 20, we had actually quite a few that I want to work for 20 as a cashier per hour. Okay? That's very good money. If they give you 500, probably, no, I want to work there. Okay? Think about it. So, we should understand this. The person is not working this does not mean that this person would not work under any circumstances. Actually, this person is not working because this person does not like what they can get when they work. Right? That's the actually correct way of thinking about, this type of choice. Okay. Well, actually, for example, if you can, pay anybody any amount you want, you can make any person to work for you. Obviously, okay, you can do that easily. If you have infinite resources, then you can make any person to work. Why? Because the person's choice depends on the wage rate. Okay, so that's the concept we want to use. That's the reservation wage. What is the reservation wage? Since the reservation wage is the wage rate that can make this person start working. Okay, so that's the reservation. So this is the wage. This is not like the market wage you can actually see. Market wage, you can see that, okay, how much do they pay to the cashier at the convenience store? You can see that. Okay, they get around $5 per hour, okay, in US dollars, around $5 per hour. But reservation wage is not the one that you can see. Why? Because this is reservation wage. For an individual, the reservation wage is the wage level this person is willing to work if the wage rate is higher than this level. Okay? And we can formally define that reservation wage is the wage level where an individual is indifferent between participating in the labor market, or we can, in short, working, and not participating in the labor market, or in short, not working. Why this is the indifferent level? Because the wage rate is a little higher than this level, this person will surely be working. If the wage rate is a little lower than this person is surely not working. Okay? So this is the threshold. This is like a minimum. Like this person is, willing to work. Okay, get it? So reservation wage itself is an interesting thing, that each individual has a reservation wage. Regardless whether they realize it or not, you have a reservation wage. Each of you. You are not working because the wage rate is lower than the reservation wage. When I said that, although it was a hypothetical thing, when I said that $20, then some of you raise your hands. What does it mean? It means your reservation wage is lower than the $20. It's higher than $10, but lower than the $20. But others still, for 20 I would not work. Then which means for the others, the reservation wage is above 20. Okay? And I said, why 500? Then everyone wants to work. That means what? Everyone's reservation wage is lower than 500. Okay? So we cannot see it. But actually, in a way of seeing it is, if the person is working for a certain level of wage, then we know that this level of wage is at least, it cannot be lower than the reservation wage. If this level is lower than reservation wage, this person should not be working right now, right? So that's how we look at the people who are not in the labor force, and we just look at the reservation wage. Okay, the concept of reservation wage is very powerful in that sense. Okay, so that's what I just said. So then, how do we find the reservation wage? Actually, using a diagram, you can easily find the reservation. If we know how this individual's indifference curve looks like, then we can actually pinpoint the reservation wage. How do we do that? Now, think about it. Think of an individual who has an indifference curve that has this shape. Okay? Okay, first thing is that we have to have a starting point. We have a benchmark point, which is this. Okay, this point is the point of not working. Okay? And this indifference curve goes through, the black one, indifference curve goes through this point E, and then utility level of U0. That means what? This person, if this person is not working at all, this person would get utility level U0. Okay? So to make this person work, obviously that working should give this person in utility level higher than U0. Okay? And so how do we do that? Okay, think about it. Now let's make a hypothetical wage rate. Okay? For example, let's try this wage rate, W low, like $5 per hour. Okay? Now, if I suggest $5 per hour, then this person will solve the optimization problem at hand. And that's going to look like, okay, I have a wage rate that has this slope. My indifference curve looks like this. Then would it be wise to work or not? So if you were in this person, if you're this person, would you work for $5 per hour? No, why not? Because if you work, your utility level does not go up, but go down, right? For example, like like this point X, you can work like point X. Then your indifference curve looks like this. This is lower than this. Not good. Okay, I would rather stay here. And if you draw any indifference curve at any point on this line, you can see easily that that's not good. So obviously this one is too low. Or we can say this one is lower than the reservation wage. Then I can offer you a higher wage rate, hypothetical. Let's say $20 per hour. Okay? So $20 per hour, then solve a new optimization problem with 20. And we have this person has now this budget line, this red one. What happens? Work or not work? Working is the better choice. Why? Because if the person chooses point Y, then this person will have higher utility than this. So obviously, this person can make this person to work. That means what? Okay, 20 must be higher than the reservation wage. Because for 20, this person will be surely working. So 5 is lower than the reservation wage. 20 is higher than the reservation wage. What we want to do is we want to pinpoint the reservation wage. Then what we can try the numbers between 5 and 20. Okay? Then okay, so we have 5 and 20. So what we should do is that if the person is surely not working, that is lower than the reservation wage. If the person is surely working, that is higher than the reservation wage. What we need is to make this person just indifferent between working and not working. Okay? What is the level? You can try up and down, and at the end, it will be the slope of the line should be like this one. This is special because this one has the slope of the indifference curve at point E. Okay? So that's how you find the reservation wage, theoretically. So the reservation wage is equal to the slope at the point of not working, point E. Okay? So you can see that, okay, given this, if the slope is a little higher than this, then you can see that this person would work. A little lower than this person would not work. Right? That's the threshold. Okay, so as you can see that obviously that if you know the, let's say, utility function, or if you know the shape of indifference curve, then we can find reservation wage for any person. Okay, get it? That makes sense? Right? There are two things that determine the reservation wage. One is very obvious. The slope of the indifference curve. Okay? If the indifference curve is flatter, the reservation wage must be lower or higher. If the indifference curve is flatter, the reservation wage must be lower. If the indifference curve is steeper, the reservation wage must be higher, right? Okay, because it all depends on the slope at this point. If it's flatter, it should be lower. Steeper should be higher. So the slope of the indifference curve is closely related to the how much this person likes leisure, right? So if the person likes leisure stronger and stronger, the slope of the indifference curve gets steeper and steeper. That means reservation wage will be higher. Okay? If it's flatter, this person prefers consumption, stronger and stronger, or puts less value on leisure. So gets flatter and flatter, so reservation wage must be lower. So obviously reservation wage is different from individual to individual. Okay? That's obvious because individuals have different preferences. What they like is different. So some person is willing to work for $10 per hour. Some person is not willing to work for $10 per hour. So different. It depends on first their preference. Their preference, or we can say the slope of the indifference curve, or the shape of indifference curve. Okay, it's a preference. Okay. Oh yeah, I should look at this. So the thing is, given what we know is the person is not working because the wage rate is lower than the person's reservation wage. Let's say we have a bunch of people like you guys who are not working. Okay? Think of yourselves, let's say. Let's say this is a group of people who are not working at all. Now the market wage increases, like the exercise, the examples I gave you, like $20. Then what happened? Some people wants to work. Okay? So when the wage goes up, then the percentage of people who are willing to work will increase. It's not everyone. Okay? When the wage goes up, then the individual who have relatively lower reservation wage, wants to start working. So it's not everyone, but there may be some who are willing to work. Okay? When the wage goes up, it does not make the percentage of people who are willing to work lower. It cannot make it lower. Okay? I mean, obviously. Yeah. So when the wage goes up, we can say that for this group of people, the percentage of workers will increase. When the wage goes down, the percentage of workers will decrease. There may be some people who are working at this level, and this level of wage is just slightly higher than the reservation wage. Let's say the market wage falls. Then this person will say, oh, I quit. Okay, this pays nothing. I quit. Some may be still working, but some would quit. So for that group, the percentage of workers will decrease. So it is important that to understand how the wage level and the labor force participation rate or percentage of workers are related. If there is only one direction, wage goes up for a certain group, then labor force participation rate or percentages of people who are willing to work will increase only one direction and goes down because everything will be compared against the reservation wage. Reservation wage for individual is fixed. Okay? Depending on their circumstance, depending on their preference, but there is another thing. It's fixed. So only thing that wage goes up, then LFPL likely to increase. Not every time, but likely to increase. LFPL, when wage goes down, LFPL likely to decrease. So that's what I just said. And when you think of income and substitution effect, we just said that for this person, appointee, there is no income effect. Okay? So only the substitution effect. So there is only one direction by the substitution effect. Okay? That's how it works. So an increase in the wage rate of a non-worker does not generate an income effect. So only the substitution effect. Get it? Okay. So, sometimes the students are confused between the choice of working hours and choice of work or no work. Okay. They are two, different logic. I mean, not different, but related, but different logic. Choice of working hours, then we have income and the substitution effect, which has opposing directions. Choice of whether to work or not has only one direction, okay, due to the substitution effect. Okay, higher wage, more likely to work. Lower wage, less likely to work. Okay, get it? Okay, one affects an individual reservation wage preference. Okay, so it's the shape. The second thing is the non-labor income. When the non-labor income goes up, the reservation wage will increase or decrease? Will increase. Okay. Now think of the lottery case. If you won the lottery, okay, are you more willing to work or less willing to work? Okay. It depends on how much you won, but anyways, you get $1 million, which is US dollars. It's actually very good money. Okay. Now, are you more willing to work? Oh, now I have $1 million in my pocket. I should go out and find work. Or, okay, this is the end of my working life. Okay. The study says 40% of people said, okay, this is the end of my working life. Okay. They dropped out of labor force, 40% of people at least. Okay. That is interesting. That's if that happens to me, you wouldn't see me from the next day, okay, because I'm not gonna be here, and I will quit. And that is probably the most cases for most people. And here actually we can show that, but I'm not gonna show too much. So intuitively, this is the thing that it's easy and intuitive. Higher the non-labor income, reservation wage is likely to be higher. Okay, so everything else equal, non-labor income goes up, then this person's reservation wage will be higher. So more difficult to make this person to work. Okay. Questions? This is a diagram that shows. Oh, let me do an exercise, textbook problem that is interesting. Look at question 2-6, page 81. We have a Shelley's preference for consumption and leisure, which is this function. Okay. What is marginal utility of consumption? What is marginal utility of consumption? Marginal utility of consumption must be L minus 80. Marginal utility of leisure, C minus 200. Okay. And says that there are 168 hours in week, $5 per hour, 320. So T is 168 W is 5, V is 320. Okay. Two questions. First, what is the reservation wage? What is Shelley's reservation wage? Can you find the Shelley's reservation wage? How do you find the Shelley's reservation wage? The reservation wage is given by what slope? The slope of the indifference curve at the point of not working, right? So what you need to do is to find the slope at that point for this person, right? How do you find the slope? mu something over mu something, right? Mu L over mu C, right? So must be something, it should come from this. But we don't know C and L. But actually we do know C and L. What is C? C must be what? C must be 320. Why? Because this person has no earnings. So at the point of not working, consumption should be equal to V, 320. Okay? Get it? Make sense? Huh? So 320 minus 200. And L must be 168. Right? Okay? Which is 120 divided by, what is it? 88. How much is this? How much is this? Huh? No, you have a calculator, right? What's the number? What is the number? 1? 1.36. You sure? Yeah, it should be 1, yeah, 1 point something. Cannot be 2. 1.36? Can I believe you? Okay, anyway. 1 point something. Is it? 1.36? Yeah. So the reservation wage for this person, Charlie, is $1.36. It's $5 per hour is market wage. Thus, Charlie must be working or not working. This person must be working because market wage is 5, which is way above $1.36. Okay. And what is this person's working hour, optimal working hour? How should you do that? What you should do is, we did the exercise at the beginning of this class, right? MRS equals W, right? So C minus 200 divided by L minus 80 should be equal to 5. Okay? Then you have a relationship between C and L, and put that relationship into what? Into budget line, okay? Equation of the budget line. Then you should be able to get those two numbers, okay? You try yourself, okay? The same, okay? The way of doing it is the same, okay? And there is a 2-4, which is a very similar exercise. Okay. And try the exercises, you know. Okay, now let's. Okay, now what we do is that, so we have seen the the workers' choices, okay, given wage levels, okay, whether they work or not, and how many hours they want to work, okay. So using their choices, what you can do is that we can derive each individual's labor supply curve, okay. For example, if the wage rate is $2, then this person say, how many hours work? 0 hours work, no work. Okay, so up to $2, no working. And if the, let's say, wage is 15, then we can say, okay, we can find the optimum like this. 25 like this. 15 to 25, which effect dominates which? Which effect is bigger? Sufficient or income? Sufficient effect is bigger. Okay, wage goes up, work more, so sufficient effect must be bigger. And then 25 to, let's say, 35, which effect is bigger? Income effect. Okay? So theoretically, when the wage increases, then income effect gets stronger and stronger. Okay? So actually, if you look at Slutsky equation, you can see that. So wage goes up, then income effect gets stronger. So which means that when the wage is relatively low, then sufficient effect is likely to be bigger than income effect. When the wage is relatively high, the income effect is likely to be bigger than the sufficient effect. For each individual, that changing point is different. You cannot say what number. But what we know is that is the trend, theoretical prediction that when the wage is relatively low, then sufficient effect must be bigger, stronger. And when the wage is relatively high, then income effect must be relatively stronger. So which means when the wage goes up, at first, labor supply will increase. Okay? And then, at some point, labor supply will start decreasing. So individuals' labor supply curve are going to look like. So how do we do that? Actually, we can, trace out all these working hours from the previous diagram. Just trace out them into just something like this. When the wage is 2, then desired work hour is 0, 15, and some hour 25 increase. So some gonna look like this. Okay, you get it? So the 0 hours. So this $2 is what wage? It's the reservation wage. Okay, below 2, no work. Okay. So here we call this individual labor supply curve because we draw it only for one individual. And below 25, and then we have this positive slope, then sufficient effect dominates income effect, and negative slope, income effect dominates sufficient effect. And then there is a name for this one because this curve looks like bending backward, okay, forward and bending backward. So we call it backward bending labor supply curve. Okay. Okay, so each individual has, something like this. And so market labor supply curve is just that we just add up everyone's desired work hours, and we get the market supply curve, market labor supply curve, right? So if we have like only 2 individuals in the market, what you can see is that up to WA, what is the market labor supply? 0 to WA, market labor supply is 0, right? This person is not working, this person. Between WA and WB, what is the market labor supply? Only HA, okay? And above WB, HA plus HB, okay? So that's going to look like something like this. Okay? Get it? If you have backward bending, then we can still do the same exercise. But anyway, okay. So this is the how we derive the market labor supply curve. Horizontal sum of individual labor supply curves. Okay, let's stop here today. Okay, and then next week we'll start at labor supply elasticity, and then finish our discussion on labor supply. Okay.